Hello, recording quick video for you guys outside my dance room because I have a bunch of dancers who hang out in there and they don't want to hear me talking about physics necessarily. So, so I'm recording this quick video for you guys for our last lesson finally in the energy unit. So, in everything we've talked about, in all of the formulas, so we have kinetic energy, potential energy, work. There's a quantity that we haven't talked about yet. So kind of look over those formulas and see what is not a quantity we have worked with a lot in the past, what's not involved in any of those. None of these so far have involved time, actually. It's not a quantity in work or energy, right? Work is force time distance. Energy, depending on it, we have 1/2 mv squared. We have mgh. So you've got acceleration, right? Because g is acceleration due to gravity, right? But there's no time. So we can talk about this quantity when we discuss the rate at which work is done on a system. The rate of work done in respect to time is called power. So this is our last formula we're going to be learning. Because, yeah, I can exert a force. Yeah, myself, I can exert a force. But can I do that consistently over time? Can I transfer that energy over time? So this is power. Yeah, you want to kind of think about it like that. If you can consistently transfer this energy and exert this force, over a lot of time, you've got more power, right? You're stronger. So this is the formula, again, because power is the rate of work in respect to time. This is the formula on the formula sheet. We know that work equals change in energy, right? However, even though this is the only formula, we can change this in several different ways. And the kind of frustrating thing is that every single time that you see a problem that you think involves power, you need to be able to go through all these iterations, I call them, because we can derive a bunch of different things from this formula. So again, we know that, I gotta write this crap. I got a stylus here, I think. Haha, okay. So we know that again, the basic formula we just said is that power is change in energy over time. But again, we know change in energy to also be what? That's work, right? Work over time. Yeah. But we also know that work has a special formula for it. What is the formula for work? That is force times distance over time. So we could also look at it like this, right? Lastly, there's something within this formula that we can actually change to be something else as well, right? I have this force here, but we also have this distance over time. Distance over time, distance divided by time, is actually a quantity that we know very commonly to be what? Distance divided by time. Well, I still have the F, but distance divided by time is actually velocity or speed, right? So very often, again, it could be any one of these versions of the formulas that you have to think in terms of. So you have to be able to go, okay, change in energy is work is force distance, but distance over time is velocity. You have to be able to generate those whenever you're thinking of power. Now, again, AP test likes to be tricky. Very often they will not use the word power, but they will say rate of work. You should think power. In the same way that if we read change in energy, that says energy. Ooh, that does not look like energy. Energy, there we go. Um, what is change in energy? Work, right? So if I say rate of work or rate of change in energy, this is then power. So we have to be mindful about that vocabulary. If we don't know those definitions, we don't know they're talking about power, which we have a formula for. So take a second. All you're going to do now for this last slide is just make your note cards. I'm going to scroll down. That's everything right there. And then we'll talk more about this tomorrow. So again, all you're doing, make the note card, and then you're done.